Hi guys, another day, another build project. This build being more for practical reasons as opposed to most of my other builds which are for nostalgia and fun. The day has arrived for the decommissioning of my main rig. This is my UnRaid server I am currently disassembling, which I built during 2020 and has been a brilliant cost-effective solution to my storage needs. It also has been used as my render server for all of my videos. As energy prices fly through the roof here in the UK, it's encouraged me to integrate my main rig into my UnRaid server using a virtual machine and enabling GPU pass-through to my Zotac GTX 980 so that I will still be able to continue to play some games. This should reduce my energy consumption by up to 520 watts, which is the maximum rated output of the PSU in my current rig. The migration will be a significant upgrade to my system performance compared with the Intel i7-960, which is a 4-core 8-thread CPU clocked at 3.33 GHz. The dual Intel Xeon E5-2440 V2 CPUs clocked at 2.4 GHz have 6 cores and 12 threads each, which will be a significant performance boost, especially rendering video. The second upgrade is also significant, quadrupling the amount of memory available from 16GB of RAM to 64GB of RAM, with the added feature of error correction control as we're running server grade DDR3. I have tested GPU pass-through in the past, but literally as just a test, but this is going to be the ultimate test, a complete migration. You may be asking why I'm completely stripping my server from its 4U chassis. Well, this is all going to be built into the case of my current rig. All of this hardware that I will be using is relatively old, over a decade old in fact. The motherboard was released on the 22nd of May 2013 and the CPUs in September of the same year. Up to now I've had no problems and you can pick up all this kind of hardware reasonably cheaply. And that is the ultimate aim of this project. Cheap and cheerful. So, what are the advantages of using a virtual machine? Virtual machines provide a level of isolation from the host system, each operating independently with its own operating system and applications, which reduces the risk of conflicts between software and helps to contain any issue that arise within the VM. They allow for better utilization of hardware resources by running multiple virtualized environments on a single physical machine. This means you can consolidate several servers or workstations onto one physical server, reducing hardware costs and energy consumption, which is the main aim of this project. Virtual machines are highly flexible and can be easily configured, cloned, or migrated between physical hosts. This flexibility means it's easier to scale resources up or down based on demand, perform maintenance without downtime, and to test new configurations or software without affecting the production environment. Security can be enhanced by providing a sandbox environment for testing potentially harmful software or running untrusted applications. If a VM becomes compromised, it can quickly be isolated and restored without affecting the host system or other VMs. The backup disaster recovery process is simplified as you can easily take snapshots of the VM, which capture their entire state at a specific point in time, making it easier to roll back to a known good state in case of data loss or of system failure. Invaluable for development and testing purposes, as developers can create virtualized environments that closely mirror production systems, allowing them to develop and test software in a controlled environment. VMs enable running legacy software on modern hardware by emulating older operating systems or hardware configurations. This helps organizations maintain compatibility with older applications while migrating to newer infrastructure. Overall, virtual machines provide a cost-effective, flexible, and secure way to deploy and manage IT resources in a variety of scenarios. Now to the disassembly of my current system. Onto the assembly now, where we're just going to simply transplant all of the hardware from my UnRaid server into this fractal design Vector RS blackout dark tempered glass MIDI tower case. This case has much better airflow and many more fans, 6 in fact, that will help to disperse that heat. There is only one front fan in the 4U rack chassis, so the drives were getting a little bit toasty. GPU pass-through, also known as GPU virtualization or GPU assignment, involves dedicating a physical GPU to a virtual machine, or VM, allowing the VM to have direct access to the GPU hardware. Some advantages of GPU pass-through are that it can significantly improve graphics performance for virtualized environments, especially for tasks such as gaming, graphic design, video editing, or machine learning. By providing direct access to the GPU, VMs can leverage the full capabilities of the hardware without the overhead of emulated graphics. GPU pass-through enables running applications that require specific GPU features or drivers within a virtualized environment. This can be beneficial for software development, testing, or ensuring that sensitive GPU accelerated workloads are not affected by other VMs running on the same host. Dynamic allocation of GPU resources to virtual machines based on workload requirements, which administrators can easily adjust GPU assignments or migrate VMs between hosts without disrupting running applications. Some of the disadvantages of GPU pass-through are compatible hardware, including a CPU with virtualization extension such as Intel VT-D or AMD-VI, and a motherboard with support for IOMMU, or Input-Output Memory Management Unit. Not all hardware configurations support GPU pass-through, which can limit its availability. It can be complex and require advanced knowledge of virtualization technologies, hardware compatibility, and system administration. Setting up pass-through requires careful configuration of the hypervisor, BIOS settings, and device drivers, which can be challenging for inexperienced users. While GPU pass-through provides improved performance for virtualized workloads, it also induces additional resource overhead compared to traditional virtualization techniques. Managing GPU resources and ensuring optimal performance require careful monitoring and tuning of the system configurations. May not be officially supported by all GPU vendors or virtualization platforms. Lack of vendor support can lead to compatibility issues, driver limitations, or stability problems, especially when using consumer-grade GPUs in enterprise environments. Overall, GPU pass-through offers significant performance benefits and flexibility for virtualized environments, but requires careful consideration of hardware compatibility, configuration complexity, and vendor support. As you may or may not have noticed, I have just installed a PCI graphics card, and that is because this motherboard does not have an integrated VGA display, and that generates some problems, because UnRaid needs its own GPU. I had attempted to use the GT610 in an 8X slot, but UnRaid would always assign the GPU in the 16X slot as the primary display, and I could not find a way to change that. It would not have been a problem if the motherboard had multiple 16X slots, but thankfully installing a much older PCI GPU encouraged UnRaid to use that card instead, freeing up the PCI-E 16X slot for the GTX 980. Well, that's all the building work now complete, so now let's fire this thing up and then we should be able to access the web interface, because we need to adjust a few little things before I can use my VM as intended. My previous VM used a virtual disk, whereas I want to use my 120GB SSD as the boot disk and a 1TB hard disk as the storage disk on my virtual machine. On the dashboard you can see everything so far is looking pretty sweet. At this point I've already stubbed from the system devices, the SATA controller and the USB 3 controller, and installed Windows onto the SSD, so my virtual machine is already up and running. We can see that all of our cores are working as they should be. And as we scroll down you can see we have 80GB of DDR3 multi-bit ECC memory, 85% being utilised by my virtual machine, leaving a healthy 16GB of memory available for UnRaid and any Docker containers that are running on the server. we've got a 1 gigabit network connection on F0, and on F1 the interface is down, or in other words, not connected. In my virtual machine settings, I have it set up with 20 cores available for my VM, leaving 4 available for UnRaid and Docker containers. 64GB of memory is assigned to the VM, running an i440FX 5.1 machine, OVMF BIOS, and Hyper-V is enabled. The primary VDisk location is now set to none because we're not going to be using a virtual disk as the boot device. The graphics card is set as the NVIDIA GeForce GTX 980, and there is an option to select the graphics ROM BIOS, but I've not needed to use this feature. The sound card is selected as the onboard Intel C600/X79 series chipset HD audio controller, network source and network mode, and here right at the bottom we have some quite important items that need to be enabled for the VM to work. For example, the SATA controller that I have stubbed, and the USB 3 controller which I have also stubbed from the system devices. Now we will look at how to stop system devices from being used by UnRaid. Go to Tools and then into System Devices. Just give it a sec to load. And here in the list of IOMMU groups are all the devices on the system, and it is simple as ticking off what you want UnRaid to essentially ignore and leave available to the virtual machine. Okay, so this is what we get on our screens. The left hand screen is the display from the VM, and the screen on the right is the display from UnRaid. To boot the virtual machine, I need to type exit, which will exit the shell and load the bootloader. Go into Boot Manager and select our boot device, which is the OCZ Agility 3 120GB SSD. Hit enter and boom! VM is now loading. Lovely, lovely. And that is it for this video. I'll more than likely do a follow-up video with an update on any issues or changes, and possibly some benchmarks to review performance, just to check on that GPU pass-through. Thanks for watching and take care.